So hari ini apa yang kita akan belajar adalah berkenaan dengan structural equation modeling lah. Structural equation modeling ataupun kita panggil juga sebagai SEM. SEM ni nanti kita kena differentiatekan. So bila kita sebut tentang structural equation modeling, sebenarnya dia refer kepada apa yang kita panggil sebagai data analisis teknik. Okay. So jangan salah faham. So ini adalah data analisis teknik. Sebab macam semalam pun saya baru habis memeriksa satu tesis PhD. Bila dia describe on data analysis, dia tak tulis structural equation modeling, sepatutnya dia hanya tulis sebagai smart PLS. So smart PLS is not data analysis teknik lah. Bukan data analysis teknik. So smart PLS is actually a software sahaja. Okay. So bila kita masuk workshop, okay. So kalau dia kata workshop dia AMOS, actually tak betul lah, okay. Yang mana AMOS ni adalah software sahaja, okay. So apa analisis, data analisis teknik yang digunakan? Hari ni kita akan belajar tentang satu lagi data analisis teknik yang biasa digunakan dan advanced data analisis teknik, iaitu structural equation modeling lah. Okay, so kena faham. Alright, so hari ni kita nak gunakan, apa yang kita akan belajar hari ni adalah berkaitan dengan penggunaan software AMOS lah untuk kita run structural equation modeling. Right, so apa yang kita akan buat hari ni adalah belajar tentang the basic concept sehinggalah kita akan analyse the direct effect yang kita akan, the direct effect lah basically. Kita tak akan go sehingga, kita akan pergi sehingga mediation or moderation unless kalau kita ada masa. So sesi ni sebenarnya dia adalah sesi workshop ni selalunya kita buat 2 hari. Yang mana sesi 2 hari ni adalah hands on betul-betul lah. Tapi untuk workshop yang kali ni yang mana kita dah cramkan, kita nak cramkan 2 days punya workshop, content dalam tempoh 4 jam ni saya rasa basically takkan banyak hands on lah. Maksudnya you akan hanya dengar dan hopefully you can join saya dengan bertanyakan soalan yang berkaitan lah. So kita ada interaktif punya workshop lah. Alright, so basically untuk bukan kata day one lah, apa yang kita akan belajar first ni, untuk the first session, so kita basically kita akan belajar tentang the concept lah. Okay, to describe what is SEM, apa yang kita masukkan dengan SEM, to explain the SEM approach. Sebab sebenarnya kena faham bahawa bila kita sebut tentang SEM ni, kita ada sebenarnya 2 approach. Okay, bagi those yang belum lagi akses saya punya slide, boleh akses lah di sini, boleh scan. Alright. So kita akan explain the SEM approach. Maksudnya kita kena faham betul-betul ada 2 type of approach regarding SEM ni. Kemudian kita akan strictly concentrate ataupun fokus on the CB-SEM. Kenapa? Sebab CB-SEM sahaja. Kita akan zoom in kepada CB-SEM. Kenapa CB-SEM? Sebab hanya CB-SEM saja yang menggunakan AMOS. So AMOS tu adalah satu software yang kita boleh gunakan untuk untuk run the CB-SEM. Okay. Kena faham approach yang berbeza, approach SEM yang berbeza memerlukan software yang berbeza. Okay. Kemudian kita akan explain the basic concept of SEM. So tak kisahlah sama ada dia adalah PLSM ataupun di CB-SEM. So basic concept dia kena sama sahaja. Kemudian apa yang bezanya antara CB-SEM dengan PLSM adalah the assumption of SEM. Sebab CB-SEM ni dia agak rigid with respect to the assumption. Sebab dia ada kena penuhi beberapa assumption dulu. Kemudian kita akan terangkan step in conducting SEM. Kemudian kita akan juga expose berkenaan dengan software-software yang boleh digunakan untuk conduct SEM. Dan juga kita akan basically kita akan terangkan juga how to construct model in SEM. Yang ni kita akan belajar how to manually construct. So in case kalau kita guna plugin dan katakan tiba-tiba kita terdelete dan sebagainya, so you know what to do lah with respect to constructing the model lah. So what is SEM actually? So SEM ni adalah salah satu teknik data analisis teknik. Okay, so kita kena faham kalau kita sebut tentang data analisis teknik, okay saya conteng sikit sebab suka nama macam mana kan. Cikgu kan daripada dulu lagi suka je menconteng. So bila kita sebut tentang statistik, data analisis teknik, so kita sebut statistik. Okay, so basically kita hanya akan ada 2 statistik. Ingat tak apa dia? So kita ada 2 jenis statistik, iaitu deskriptif dan satu lagi ni saya simplify saja, deskriptif, dan juga kita ada apa yang kita panggil sebagai inferential. Okay. So setiap data analisis teknik yang nak digunakan mesti match kita punya research objective. So apa-apa jenis, sama ada apa saja, tak kisahlah apa sahaja analisis yang kita nak buat, kita kena tengok dia punya research objective. So there is no right or wrong data analisis teknik untuk selesaikan kita punya research objective. As long as kita boleh capai research objective, maka data analisis tu kira antara yang terbaik lah, the best alternative. Okay, so bila kita sebut tentang research objective, untuk differentiate ni sebenarnya, research objective ni sebenarnya kita boleh classify kepada berapa lah mengikut sama ada dia adalah statistik, deskriptif ataupun inferential. Kalau dia adalah statistik deskriptif, kalau research objective dia adalah berteraskan kepada kita nak tengok deskriptif saja, you want to describe things, okay. So ni adalah research objektif dia. Kalau deskriptif saja, contohnya katalah kita nak tengok tahap, kita nak tengok the level, kita nak tengok the mean, score dan sebagainya. So itu adalah deskriptif. Research objektif dia adalah deskriptif in nature, maka kita kena gunakan statistik deskriptif sebab kita nak describe saja. The most basic things bila kita guna descriptive analysis adalah apabila kita nak melaporkan the profile of respondent. Okay, next thing, kita ada inferential statistic. Inferential statistic ni kita boleh classify into, kalau kita nak sebutkan tentang kategori, kita boleh classify into 3 category of research objective. Yang pertama kita nak tengok the different. Okay. Yang kedua kita nak tengok in term of dia punya relationship. So relationship ni refers kepada apa yang kita panggil sebagai association. Okay. Association. Okay. Dan yang ketiga adalah berkaitan dengan effect ataupun kita punya pengaruh lah. Okay. Alright. So the effect ni, okay, kalau untuk the first generation data analysis teknik, biasanya kita akan pakai regression lah. Okay. So depending on the research objective lah. So sama ada kita akan pakai regression. Minta maaf banyak-banyak. Tak tahu kenapa hari ni tulisan saya tak sharp hari ni. Okay. So biasanya untuk the first generation data analysis teknik, regression, so kita akan pakai regression. So bergantung kepada research objective, ada yang kita pakai simple linear regression, ada yang pakai multiple regression. So kalau the best data analysis masa the first generation is called as the multiple regression. So dalam multiple regression, apa kekurangan multiple regression adalah dia hanya ada satu DV sahaja. Okay, only one DV, tapi dia boleh ada multiple IVs. Okay. Dia boleh ada IVs, tapi dia hanya ada satu DV sahaja. Dia tak boleh ada lebih DV. Okey, kalau kita ada lebih daripada satu DV, so kalaulah kita kata kita decide nak guna juga multiple regression, so what you should do, you akan buat dua kalilah, twice. Okay, the similar framework tu you test it twice, okay, dan separately. Okay. Jadi untuk nak mengatasi masalah ni, kita come out, bukanlah kita lah kan, okay, the scholars come out with apa yang kita panggil sebagai structural equation modeling. Okay. So apa bestnya structural equation modeling? Structural equation modeling adalah dia merupakan the comprehensive multivariate technique. Kenapa? Sebab dia combining almost every data analysis technique in the inferential statistik. Okay, so sebab itu kita panggil dia adalah comprehensive. Kenapa lagi penting? Sebab it can test simultaneous analysis of a series of direct or indirect dependent relationship between multiple independent and dependent variable. So meaning that kalaulah kita ada lebih daripada satu DV, kita ada mediator, kita ada moderator, kita juga nak test on the nak validate the item. So kita the best data analysis technique, kalau terlalu kompleks yang macam tu, so the best data analysis technique is actually structural equation modeling. Okay, so structural equation modeling adalah the second generation punya data analysis technique. Okay, sebab itu in your chapter 3, kalau you describe data analysis technique, you jangan sebut tentang AMOS, you jangan sebut tentang Smart PLS. So that is not the technique, that is the software that you use. Okay. Tapi janganlah kata tak boleh, oh doktor kata tak boleh mention. Sebenarnya mention lah juga bila you nak menyebut tentang you nak gunakan apa, Smart PLS ke, sebab kita pun ada SPS, SPLS juga kan. Okay. So banyak sebenarnya software yang kita boleh gunakan. Alright. So seterusnya ia adalah advanced statistical technique that incorporates factor analysis, path analysis and extend the purpose of correlation, analysis of variant, ANOVA, factor analysis, ni double lah, and juga multiple regression. So kalaulah okay, nak buat perbezaan, kalaulah nak melihat dari segi macam tadi, kita ada multiple dependent variable. So the best analysis technique, bila model you, kalau you nampak kompleks sangat, okay, kalau hanya one to one, kan, kalaulah kata kita hanya ada variable ni, kita ada one to one, okay, satu kepada satu macam ni. So yang ni straight away memang regression lah. Okay, kalau kita doublekan juga dia punya independent variable, so kita pergi macam ni. So ini masih lagi valid untuk kita gunakan multiple regression. But kalaulah katakan kita ubah sikit, okay, so kita pergi sini. Alright, so kita ubah ke sini. Okay. So minta maaf saya punya pen hari ni ada masalah. Dia macam tak sharp. Okay, katalah kita nampak macam ni, okay. Sebab sekarang ni kita ada dua dependent variable. Yes. Ada nak tanya ke? Ada nak tanya ke? Tak ada. Right. Aidarina. Anything to ask? Nak tanya ke?
Maaf Doktor, minta maaf, saya tukar device.
Okay. Alright. Kalaulah kompleks macam ni, yang kita nampak ni kan, kita tak nak test it twice, 2 kali, 3 kali, 4 kali dan sebagainya. So apa yang perlu kita buat adalah kita switch kepada structural equation modeling. Sebab hanya sekali run saja kita dah dapat all the solution untuk this model lah. Okay. Right. Seterusnya, saya agak laju kalau you all nak tanya terus sebab kita nak cram everything in 4 hours kan. Right. So kalau ada nak tanya, just stop me lah dan terus tanya sajalah. Right. So kita ada dua jenis approach macam saya cakap tadi. We have two approach of SEM. Kita ada dua jenis sebenarnya. Satu yang kita panggil sebagai covariant based SEM dan kita ada partial least square SEM. Okay, ataupun selalunya kita akan pakai, biasanya kita kenalkan dia sebagai PLS-SEM lah. Alright. Walaupun dia depends sebab kita ada ciri-ciri yang tertentu untuk define kenapa bila masa kita nak guna covariant based SEM, bila masa kita nak guna PLS-SEM, tapi the PLS-SEM should be considered as an alternative where CB-SEM could not be used for any reason. Okay, kena faham itulah. Bukanlah kita kata kalau guna CB-SEM kena pakai CB-SEM saja, tak boleh pakai PLS-SEM. Bukan. Okay. So sekarang ni saya strictly pergi kepada when to use CB-SEM. Okay, kenapa saya start kat sini? Sekarang ni kita lebih merujuk kepada CB-SEM. So basically, kalaulah research you menggunakan filosofi, research philosophy is positivism. Maksudnya we want to have one, kita nak satu jawapan yang tepat. Dan kita nak very objective dan kita aims to generalize. Maka the best data analysis technique, kalau model yang kompleks, okay, maka kena gunakan structural equation modeling ataupun kita panggil juga CB-SEM. Okay, tapi kalau your case is you nak buat exploratory, maka the best data analysis walaupun you kata SEM tapi kena pakai PLS-SEM. Okay. Tapi ada juga yang menyatakan kalaulah positivism masih juga boleh guna PLS-SEM. So bergantung kepada your argument. Tapi kalau ikut flow-nya, kalau kita ada theory driven, kalau kita positivism, kita nak generalize, maka kena guna CB-SEM. Okay. So seterusnya approach dia adalah kuantitatif. Bila you nak dapat, you jalankan the quantitative approach punya research. Maksudnya sama ada nak buat causal ke ataupun you nak buat deskriptif ke, yang penting explanatory. Okay. So beza antara bila nak guna CB-SEM selalunya untuk explanatory research. Okay. Right, dan kita juga buat apa yang kita panggil sebagai deductive approach yang mana we are theory driven. Okay. Bila you ada theory driven maksudnya you ada dah basis teori kat situ, dah ada dah apa teori yang you nak expand, yang you nak extend, yang you nak modify, maka the best data analysis technique is CB-SEM. Okay, kena pakai CB-SEM. Right. So basically apa yang kita nak buat to test a theory driven hypothesis. Bila kita nak test the theory, bila kita sebut tentang nak test the theory, sebenarnya dia ada 3 definition. Okay, yang pertama adalah apabila kita nak confirm the theory. The theory have been introduced maybe in Pakistan, then somehow you nak test, nak confirm the similar theory in different context. So itu adalah to confirm the theory. Jadi bila nak confirm the theory, the best data analysis technique is CB-SEM. Okay. Secondly, kalau you want to compare the competing theoretical model. So kita ada model A, kita nak model B. Kalau nak solve the problem, which one is better? A ke B ke model tu. So we want to compare the competing theoretical models. Jadi apa yang the best data analysis technique adalah kena pakai CB-SEM. Dan juga satu lagi yang terakhir adalah to test the modified model. Yes.
Doktor, kalau kita gunakan CB-SEM untuk adaptation dan adopt instrumen, boleh ke tak ada doktor?
Adopt dan adapt, apa maksudnya? Yang tu nak validate saja.
Kita nak buat reliability and validity of instrument yang luar negara kepada dalam local usage.
Boleh?
Untuk adopt. So mana
Cuma
kita
ni dia
menggunakan
tak buat
CB-SEM kan?
full SEM tau. Bila
Dia tak buat
you,
full SEM.
your aims, your research objective is just to validate sahaja, maksudnya you tak pergi kepada full SEM. Bila you nak validate sahaja, dia akan pergi, sebenarnya dalam SEM ni, sebenarnya dia ada dua stage. Okay? Kalau you hanya nak validate sahaja, okay, maka you should end until CFA sahaja. Dalam SEM. Tapi kita akan pakai SEM juga. Tapi CFA ni adalah bila you test the measurement model sahaja. You test the item, the structure, the construct, the measurement model tu. Okay, maksudnya you tak pergi kepada the structural model. Unless, kalaulah memang alang-alang selalunya bila kita nak validate, selalunya mesti kita nak analyze in the real punya context. Kan? Okay. Kemudian mungkin you boleh daripada CFA tu, you boleh proceed dengan structural model. Boleh.
Okey.
Tapi
Tu
yang ni
selalu
tak perlu
maknanya
data yang
EFA
banyak
tu,
lah.
kalau EFA tu kita buat EFA dahulu, selepas EFA baru CFA kan?
Betul.
Jadi maknanya kita boleh anggap EFA ni sebagai salah satu prosedur untuk pilot test tak? Boleh tak doktor?
Boleh. That's
Okey,
the
faham, doktor.
actual step sebenarnya.
Okey, terima kasih
Memang
doktor.
kena go through kalau betul-betul nak validate, tapi in your case you bukan newly build. You hanya adapt dan adopt sahaja. So adapt dan adopt sahaja. You tak perlu pergi a very thorough AFA. Sebab you bukan newly build. You adapt dan adopt sahaja. Jadi you hanya buat satu CFA, satu EFA dan masa pilot dan masa the actual data you buat CFA je lah.
Okay, terima kasih doktor.
PhD. Master or PhD?
PhD doktor. PhD.
Kalau PhD kan, tak cukup sampai CFA. You need to prove juga in real context. Contohnya, betul ke elemen tu sesuai? Betul ke the index or the scale is appropriate? Contohnya kalau you nak buat, nak menunjukkan the scale for improving something lah, katakan improving the student performance. Jadi you kena buat juga the structural model to test, tapi tak perlu ambil data yang banyak pun sebab your major aims, your scholarly contribution adalah pada measurement model sebab you nak validate the scale. Dan bila structural model ni just to prove saja ada ke tak ada. Basically kita selalunya dia kena the minimum is 30 lah. So 30 onward lah, boleh lah. To 100, okay lah. Tak perlu banyak sangat pun sebab you just nak prove saja. Sebab kena differentiate between apa yang kita panggil sebagai the scholarly contribution lah bila buat PhD. Right?
Masih
Boleh
Prof.
saya continue?
Masih.
Okay. Alright. So yang lagi adalah to test the modified model. Modified model ni can be, dia ada banyak kaedah sebenarnya, especially for PhD kan, bila you nak create something new, novelty in the context of your research tu, kadang-kadang bukan kita buat create memang totally new model, tak. Kadang-kadang contohnya katakan kita ada the standard model. Standard modelnya contohnya kita ada A, kemudian kita ada B dan kita ada C saja. Katalah ini standard model. Okay, right. So, what kind of modification yang you boleh buat sebenarnya for your PhD katakan. Okay, biasanya apa yang selalu student buat dia akan add in variable lah. Okay, so boleh juga, so the standard model ni yang warna merah ni, kemudian kita boleh add in satu lagi model, satu lagi variable, mungkin CD, kemudian sama ada dia ni akan bertindak as indicator pun boleh, okay, or do you nak treat dia as mediator pun boleh, kan. So itu kita anggap sebagai apa yang kita panggil sebagai modification juga. Okay, ni contoh. Sebab yang hijau ni is something that deviate from the standard model lah, standard theory. Okay, ni satu. Alright. Satu lagi yang jarang student buat adalah the multidimensional. Okay, katalah we have the standard theory. Okay, somehow bila you baca dekat dalam artikel, journal article, then you found that A ni sebenarnya dia ada dimension or dia ada further attributes yang belum explore, kan, yang belum explore lagi lah. So mungkin dia ada A1 and A2. Okay, so apa yang you nak buat adalah instead of testing A tu as unidimension, so what you want to do to improve this standard model adalah you want to look into the role of the multi-dimension here. Okay, so jadi you pun tambahlah kat sini. Okay, so A ada differentiation sebab apa? Sebab kita dah letakkan dia as multi-dimension. B ni retain, benda yang sama. So ini pun kita consider as modified model. Okay, so where does your contribution, your scholarly contribution lies? So kalau untuk this kind of model, you addition of D here, okay, dan mungkin you test juga the mediation of D here, can become the scholarly contribution, especially for PhD lah. Okay, so you need to really define this, kenapa kena add, tapi kena ada lah. Sebab bila kita sebut tentang theoretical framework, you need to argue lah kenapa nak kena add in this D dan sebagainya lah. And for this case, kenapa you nak split from unidimension to multidimension, kena ada argument lah. So scholarly contribution, kalau kita tengok kat sini, inilah yang warna hijau ni is your scholarly contribution. Alright, so berbalik kepada CB-SEM tadi, okay, dia adalah the most appropriate data analysis technique to test a model comprising a minimum of 2 IVs and more than 1 DV. Okay, yang mana all the variable tu mestilah dia punya measurement scale dia, measurement level dia mestilah interval or ratio sahaja. Dan sebab itu, kenapa saya nak highlightkan interval or ratio sahaja, dia akan terkait dengan your questionnaire. Okay, your respond scale yang digunakan untuk untuk obtain the data, kan. Biasanya ni the most common respon yang selalu student akan buat is strongly disagree, kemudian hingga kita ada strongly agree, betul? Okay, tapi apa yang selalu student buat adalah dia akan full label, dia akan buat full label. Okay, sorry, sini disagree, sini maybe neutral, kemudian sini agree. Okay, so dia ada 1, 2, 3, 4, 5. Okay, dia akan jadi macam ni. Okay, this is 1, this is 2, this is 3, this is 4, this is 5. Okay, Sebenarnya, kalaulah katakan you proceed dengan kaedah ini sebenarnya, kalau you baca betul-betul buku statistik, apa yang you buat ni sebenarnya hanya akan obtain apa yang kita panggil sebagai ordinal data. So ordinal data, you tak boleh pakai parametric test, you tak boleh nak buat ANOVA, you tak boleh nak buat t-test, you tak boleh nak buat correlation, correlation boleh, you tak boleh nak buat multiple regression or regression, dan juga you tak boleh nak gunakan CB-SEM. Okay, sebab dia adalah all those yang tadi, yang data analisis teknik yang saya dah mention tadi tu sebenarnya adalah untuk parametric test. Okay, yang mana kalau macam ni, data yang you obtain adalah data ordinal. Kenapa ordinal? Sebab dia adalah full label. Full label tu maksudnya, satu maksudnya strongly disagree, dua maksudnya disagree, tiga maksudnya neutral, empat adalah agree, dan yang kelima adalah strongly agree. Dia tak ada, kita tak boleh nak terima sebenarnya dalam skill yang macam ni, kita tak boleh ada value contohnya 3.7. Kenapa? Sebab there is no such thing kalau dalam skill yang ni sekarang kita pakai adalah 3.7. Sebab apa? Dia rigidly label, satu strongly disagree, dua disagree, tiga neutral, empat agree, dan lima adalah strongly agree. Okay? So macam mana nak buat? Sebenarnya the best analisis teknik adalah kita akan pakai rating scale. Yes, you boleh pakai, you nak kata oh saya sebenarnya pakai Likert scale. Yes, boleh pakai Likert scale, tapi gunakan extreme level Likert scale. So what is extreme level Likert scale? Apabila dia hanya ada 1 to 5 sahaja, which 1 ni adalah strongly disagree, 5 ni adalah strongly agree. Tak perlu nak buat full level. Jadi bila dia adalah strongly disagree dengan strongly agree, ini kita panggil sebagai numerical rating scale, ataupun kalau nak gunakan terms Likert scale juga, dia adalah extreme level Likert scale. So bila you gunakan scale ni, nampak macam hampir sama, tapi the second one ni will produce interval and ratio data. Tapi yang the first one will produce ordinal data. Okay, so ada beza tak? Ada beza tak? Ada juga argument nanti susahlah responden nak respon. Tak ada. Tak ada, no such thing as that. Sebab apa? Sekarang ni kita tengok rancangan reality. Kalau lah ada 5 bintang, nak bagi berapa bintang dekat persembahan artis A lah katakan. Kan orang okey je kan? Oh, please rate my beauty. Please rate my beauty. On a scale of 1 to 10. Apa tu? 10 tu adalah the most beautiful, kan? Contoh, orang dah faham konsep tu. Sebenarnya tak ada keraguan lah sebenarnya. Tapi in collecting the data, bolehlah you nak letak 1, 2, 3, 4, 5 supaya senang responden nak respon. Tapi the scale dia kena jadi 1 adalah strongly disagree, 5 adalah strongly agree. Jadi boleh kita terima tak kalau kita kata ada value, kita calculate the mean, then we get 3.7. So ada maksud lah. Okay? Boleh? So untuk CB-SEM, datanya mestilah interval ataupun ratio. So basically kita panggil sebagai scale data lah. Alright. Boleh ke? Okay. Alright, tadi saya dah mention bahawa kalau dalam SEM ni, kalau kita nak menentukan data analisis teknik, sebenarnya kita kena lihat kepada apa kita punya research objective. So tadi kita dah belajar dah semua, okay, basically. So sekarang kita pergi exercise pula, okay. Nak menunjukkan bahawa can we use SEM to test the following research objective, okay. Tengok yang pertama. Soalan yang pertama, research objective yang pertama adalah to develop and verify a scale to measure brand economic and social investment. Macam tadi saya ada soalan kan tadi kan regarding how macam mana dia nak develop and verify. Tapi ini konteks ni adalah dia develop and verify. Okay. Soalan tadi mungkin hanya nak verify sahaja. So boleh tak pakai SEM? Boleh saja, tak ada masalah. Tapi selalunya dia hanya akan berhenti, especially for master student, dia akan berhenti sehingga testing the measurement model. So testing the measurement model kadang-kadang kita panggil juga sebagai CFA, confirmatory factor analysis. Maksudnya the whole measurement model tu you nak verify whether dia fit ataupun tidak, dan dia adalah reliable ataupun tak reliable, dan valid ataupun tak valid. Okay? Alright. So sesuai tak? Okay, boleh pakai CB-SEM. Okay. For PhD, please extend sehingga the structural model. Kenapa? Sebab bila kita dah ada scale, kita dah verify the scale, selalunya akan diminta untuk kita try to prove lah. Kalau you produce the module, then you kena tunjukkanlah pada modul tu berkesan ataupun tidak untuk apa tu kita punya subjek yang kita nak kaji tu. Kalau katakan untuk improve modul untuk form 5, then kena bagi pada student form 5 lah. Kalau kita kata kit untuk apa-apa dan sebagainya, so kena reach kita punya respondent lah. Alright. Okay. So kena extend lah kalau for PhD level. Okay. So ini adalah to determine the effect of customer and brand investment on customer engagement. Okay. Selalunya saya suka sangat bila ada research objective ni, selalunya kita akan draw. Bila kalau dari research objective yang bagus, sebenarnya akan membantu you untuk lukis you punya framework. Kalau you gagal melukis framework you dengan betul, berdasarkan kepada research objective, then something wrong. Okay. Jadi kena tengok betul-betul you punya research objective. Kalau daripada research objective tu, kalau you bagi kat siapa pun, dia akan lukis your framework correctly, maka betul lah. Maksudnya well alignment lah antara research objective dan you punya framework. Okay. So kita ada customer brand investment. So kita ada customer investment, kemudian kita ada brand investment, kemudian kita nak tengok the effect on dia punya customer engagement. Okay. Kalau tengok kat sini, ayat-ayat yang saya gunakan adalah ayat yang straightforward. Okay. Tak perlu dalam research sebenarnya, dia memang ayat dia kena straightforward. Tak perlu nak guna ayat yang berbunga-bunga dan sebagainya. Okay. Alright. So, ini adalah framework untuk research objektif yang kedua. Sesuai tak? Soalannya, sesuai tak pakai CB-SEM? Anyone? Sesuai tak pakai CB-SEM? Adila Ramli. Sesuai tak? Lupa je saya klik nama ni. Adila ada? Adila. Tak ada. Ahmad Rusli?
Boleh doktor.
Boleh.
SEM.
Adakah CB-SEM adalah teknik yang terbaik? Data analisis teknik yang terbaik? Ni framework dia untuk research objektif yang kedua. Paling best sekali, the best data analysis teknik untuk framework ni, untuk model ni sebenarnya apa? CB-SEM kah? Tak apalah saya jawab. Oh, we have Ara here. So I need to speak in English. Okay. So we have CI, we have BI, we have 2 independent variable and we have 1 dependent variable. Okay. So if you have this kind of model, so the best data analysis technique is actually multiple regression. Only multiple regression. Okay. If you decide on to use your SEM, structural equation modeling. So why so? So you need to decide why. Is it inappropriate to use CB-SEM? No. You can still use CB-SEM. Why? So you can find. Why do you need to justify? You can find. You need to justify why you want to use the CB-SEM. Okay. Maybe because you want to verify the scale here. Because you want to verify the scale here. Although all the scale here are whether adapted or adopted, okay, but somehow maybe because due to we have different sources of these items to measure the CI, the BI, and the CE here, okay, the customer and brand investment on customer engagement, then that is why you want to proceed with the CB-SEM, okay. So if, okay, you only want to prove on the model, this simple model, and all the items from you adapted from a single sources. So maybe there is no need for you to proceed with CB-SEM. So the best analysis technique is multiple regression, just multiple regression. Okay. Next, we move on to the research objective number 3, to investigate the effect of green attitude, subjective norm, perceived behavioral control, and green practices consequences towards Malaysian customer intention to recycle and spread positive word of mouth. Okay, how about this model? If you have green attitude, so we have green attitude, we have subjective norm, okay, we have PBC, perceived behavioral control, and we have green practices, okay, towards Malaysia intention to recycle intention, okay, and we have word of mouth. So word of mouth. Okay. So if we have this kind of framework, okay, what is the best data analysis technique? Is it CB-SEM? Any response? Okay, if we have this kind of model, okay, because we have more than one dependent variable, so the best data analysis technique is structural equation modeling. Okay, right. So next, research objective number 4, okay, to test the mediating role of customer intrinsic investment and customer extrinsic investment in the effect of brand social investment and brand economic investment on customer engagement. So the key here is the mediating effect or the mediating role. So can we use CB-SEM? So the answer is yes. Okay, so the best data analysis technique is SEM. Okay, all right. So can you use multiple regression? Yes, you can also use multiple regression, but since here we have two dependent variable, we have two mediating variable, that is customer intrinsic and customer intrinsic investment and customer extrinsic investment. Therefore, the best data analysis technique is CB-SEM. So instead of you are using the multiple regression and you need to test it multiple times, okay, because we also have multiple relationship here, okay. So the best data analysis technique, which you only run it once, so the best data analysis technique is SEM, structural equation modeling. Oh, there's another technique actually. So we can also use process. But for UPSI student, I still maybe I haven't found yet those that are using process. Okay, so another data analysis technique that can be the best technique to test multiple mediator and multiple moderator is process. Okay, but so far I haven't maybe I haven't read any thesis that use process in data as data analysis technique. Okay, right. So next, research question number 4, to assess the moderating effect of relationship duration in the relationship between customer engagement and its antecedents variable. So meaning that they have more than one antecedent variable. So they want to test the effect of relationship duration. So can we use CB-SEM? So the answer is yes. Okay, because we have the moderating effect here. If the model is simple, you can also use the hierarchical moderated regression analysis. Okay, so but the best data analysis technique is still structural equation modeling, because we have multiple independent variable here, and we want to test it once. Okay, tak perlu 2-3 kali test lah. Alright. So next, okay, so we move to basic concept of SEM. Okay, previously in the first generation data analysis technique, you are familiar with independent variable, with dependent variable, and you are familiar with the standardized beta, you are familiar with the p-value, but in structural equation modeling, we have a slightly different terms in describing the variable and in describing the p-value, in describing the beta. Okay, so what are they? First, the variable are classified into latent and observed variable. Okay, so what is latent variable? Latent variable, or also we call it as construct or factor, is actually the variable that cannot be measured directly, meaning that we need to have items in order to get the value for the construct. Okay, for example, here we have satisfaction. Okay, so satisfaction is the latent variable. Okay, why it is latent variable? Because we don't have a single measure that can define, okay, these are the value for satisfaction. Okay, for example, result. Okay, so result, we can use a single value, so it can be it can also be regarded as the observed variable or indicator or the manifest variable. So these are the questions. For example, result or the student achievement. So student achievement, you can use CGPA. So that if you only use once CGPA as indicator of the academic achievement, so that is called as the observed variable. The only measure, because you define CGPA as your what we call the student achievement. Okay, but for satisfaction, you need to have maybe more than one question that can explain what is satisfaction. That is why the items here, or the indicator or the observed variable, are the question that you ask in order to get the score for the latent variable. Okay, boleh faham kah? Okay, so the observed variable or the indicator or the manifest variable is actually the item, the question items in the questionnaire. Okay, so they are the variable used to measure or estimate the latent variable. Okay, for gender, okay, for example, gender. Okay, is it observed variable or latent variable? Anyone? Tak ada.
Observe.
Observed variable. Sebab dia directly. Okay. Right, next, we also can classify the latent variable. Okay, first we have what we call as latent. Oops. Okay, and observed variable, or we also call it as the indicator. Okay, so latent, we also call it as the construct. Okay, that is why nowadays people are familiar with construct. What are your constructs? So the construct is actually referring to the latent variable that are used when somebody mentioned about the construct. So we can be sure that he or she is using SEM as data analysis technique. But nowadays, sometimes people misuse of the construct. Why? Because even though you are using the ANOVA, even you are using the t-test, you also describe your variable as a construct. Okay, right. So we have the observed variable, or we also call it as indicator. Okay. So the indicator is actually the items in the questionnaire. Okay, if you have the items in questionnaire. Okay, next, the latent variable can be divided into two. That is the exogenous variable as well as the endogenous variable. Okay, how to easily define the endogenous variable when the arrow, okay, and with that particular variable, so it is called as the endogenous variable. Okay, when the arrow only start with the exogenous variable and it cannot and the arrow cannot end with that latent variable, so it is called as the exogenous variable. Okay, boleh faham ke? Right. So exogenous variable ini, okay, it can only serve as the independent variable, only as the independent variable. it cannot be the mediator or the dependent variable. If the variable, the latent variable, is also the independent variable and also can also become the dependent variable. Okay, here, for example, here the mediating here. Okay, then it is called the endogenous variable. Okay, so if it only serves as dependent variable, it is also classified as the endogenous variable. So whenever the arrow here, the relationship arrow here, and with that particular variable, so those variables are considered or are treated as the endogenous variable. Okay, these are endogenous variables, so endogenous variable. So basically, the endogenous variable are the mediating variable as well as the dependent variable. Okay, if it only serves as the independent variable, so this variable is classified as exogenous variable. Okay, boleh? So far so good. Right. So kita anggap faham lah ya. Alright. So next we have the models. Okay. We classified the model. Doctor, can you give the example for... Sekejap, saya tak nampak. Can you give us for exogenous and endogenous variable? Okay. Let's go back to this framework. Okay. Okay, we have what is this? We have the customer investment and brand investment, and we have customer engagement for research objective number 2. So what are the exogenous variable? What are the endogenous variable? Based on here. So the exogenous variable is actually the CI and BI. Okay, I ask then I answer. Okay, customer investment and brand investment here are the endogenous variable. Why? Because it only serves as the independent variable. Okay, whereas for customer engagement, it is not the exogenous variable, it's endogenous variable. Why? Because the relationship arrow here and with the customer engagement. Okay, so this is called as customer engagement is the endogenous variable. Okay, same goes here. The relationship, the recycle intention, and the positive word of mouth here are the endogenous variable, while all these independent variable here are the exogenous variable. Okay, next, if we have here, okay, for number 4, if we draw the models, the mediating of customer intrinsic investment, and we have customer extrinsic investment. Okay, these are the mediator. In the effect of brand social investment, we have brand social investment, and we have brand economic investment on customer engagement. We have customer engagement. Okay, so we have here. So we have model. Okay, so here. Okay, so what are the independent, what are the exogenous variable? The exogenous variable are those that can only serve as the independent variable. So the answer is brand, brand social investment and also brand economic investment. Okay, because these two variables are the only variable that serve as the as served only as the independent variable. Okay. How about the customer intrinsic investment and customer extrinsic investment and customer engagement? So these variables are the endogenous variable. Why? Because we can see here the arrow for the relationship arrow here, and with CII, and with CEI, and with the customer engagement. So these three variables are considered as the endogenous variable. Okay. All right. Boleh? Understand? Okay. All right. So we move on to the measurement structural and full-fledged model. Okay. We define what are the models, the different types of model. Okay. Why? Because in structural equation modeling, we have two steps. Okay. Two major steps. Okay. The first one is validating the measurement model. The second one is validating the structural model. Okay, so we have two steps, validating the measurement model, and secondly, validating the structural model. So validating the structural model is actually the hypothesis testing. Whereas for validate the measurement model is actually the CFA. Okay, so you need to know what is measurement model, what is structural model. Okay, so measurement model is actually the model that contain all the latent variable in a model that specify the indicator for each latent variable, covary all the pairs of latent variable, and incorporate the measurement error for each indicator. It is also known as the CFA model. So how does this model look like? Okay, so basically the measurement model, when you want to validate the model, so these are the measurement model. So these are called as the CFA model. Why? Because we run the CFA. Okay, so basically you will have the latent variable here. Okay, all the latent variable, including the independent variable and also the dependent variable, exogenous and endogenous. So you list down all the variable that you want to test, including their corresponding indicator here. Okay, right. So there are students that tend to test the measurement model separately for each construct. So yeah, maybe that is the initial step, but the last step should be combining all the variable in the framework. Okay, so that is called a complete measurement model. Okay, okay. When you want to run the EFA as well, when you want to run the EFA, so the similar model will appear in the EFA. You need to include all the construct and its corresponding indicators here, the items here. Okay, so what's the best thing about CB-SEM, about structural equation modeling? Because we also display here the error term. Okay, so you can observe the factor loading. Okay, the most familiar things in the first generation, that is the factor loading, but in SEM we use it as regression weight. Okay, okay, different term but similar meaning. Okay, so the factor loading here, we have the factor loading, we have the error terms. So what are the error terms? The error terms in layman term, it is also called as the cross loading. Okay, okay. Next we have the covariant or the correlation between a variable. Okay, so these are called as the measurement model. If you have this set of items and the variable, so it is called as the measurement model. Okay, the second one is the structural model. So the structural model is a model that indicates the relationship between the exogenous variable and endogenous variable, meaning that in structural model only have the latent variable. It only display the relationship between the latent variable. it is almost similar to the conceptual model. Okay, it is similar, almost similar to the conceptual model. Why it is different from the conceptual model? Because in structural model in SEM, we also have the error term here. Okay, we have the equation error, and we also have the covariant here. Okay, but in the actual conceptual framework, if you have the conceptual framework, it should only look like this. Okay, you need to list down all the variable in which each variable only need to have a single variable for each latent. Okay, investment, SAT, and we have ALT here, and we have pump. Okay. Okay, this is called as the conceptual model. Okay, sorry about the line. Okay, okay. What is another thing that should be included in the conceptual model? The hypothesis. Okay. So, does a conceptual model and the structural model differ? The structural model is only in the structural equation modeling, in the input side. Okay, right. But this is called as the conceptual model. Almost similar, but you cannot copy this structural model and paste it as your conceptual model, because slightly different. Okay, in conceptual model, you only depict all the relationship proposed in your hypothesis. Okay, and based on this conceptual model, we draw what we call as the structural model. Okay, so that we can run the analysis. Okay, so these are called as the structural model. Okay. Right. The last thing is we have the full-fledged model. It is a combination of both the measurement and structural model. When you want to run the whole model analysis, so you need to have the full-fledged model, but only in your AMOS. Okay, not in your thesis. Usually you only display this one when you have the result, so you can present whether it is in appendix. Usually we use, you only present the result of the full-fledged model in the appendix, not in the thesis. So in the thesis, usually, yes, you can also, sometimes you can also show the output, but usually the final one. Okay, but to ensure whether just to display whether, to demonstrate whether the path is proven or not, you need to draw the structural model. Not you cannot copy this one into simply copy and paste in your thesis. So it is not appropriate. Okay, but all the results should be in your appendix. Okay. Next, okay, we have the error. So in SEM, we have two types of error. There is measurement error and residual error. As you can see here, okay, right, we want to differentiate here. Okay, for the measurement model, we have the measurement error. Okay, okay, so it serves a similar function as the cross-loading. Okay, how about here? Here, there's also the residual error, okay, or the error for the structural model, okay. Usually, we have the R square, so it is 1 minus R square here, okay. Right. So, we have covered the full-fledged model, and we have the error. So, the measurement error is actually the portion of the observed variable that is measuring something other than what the latent variable. So maybe we have one, suppose we set the indicator, one indicator, maybe A1, to measure maybe satisfaction, okay? But when you have the residual error is greater than, with the value of the measurement error, it indicates that A1 is also measuring another construct. So if it is higher than the cross-loading, so therefore the residual error is, we call it as the higher cross-loading, meaning that it measures other factor more than measuring the corresponding construct. Okay, right. So next is the residual error. So it is the error for not considering other latent variable in the model. Maybe you omit certain construct, so it produce what we call as the residual error or the structural error, or sometimes we call it as disturbance. Right. So these are called as the SEM assumption. Okay, SEM assumption. So what are the SEM assumption? SEM assumption, there are two classification of SEM assumption. The first classification is you need to make sure that you meet the assumption before you actually produce the model. Okay, so what are the SEM assumption that you need to determine before you do or you collect the data? Okay. Okay, the first one is the sample size. So you need to determine before you run the data, before you collect the data, you need to make sure the sample size should falls within 100 to 400 or 200 is the preferable. But depending on the justification, okay, depending on the justification, okay. Secondly, the number of indicator. So the minimum number of indicator is 3, okay. These are the last items, the last contract, the last observed variable in the model, okay, in the final model, okay. These are the number of items in the final model, meaning that if you have 3, after you have run all the analysis, after you have tested the assumptions, the last number, the number of items left in the final model must be 3. Okay, so you can start with 3, but you must end with also 3. Or it is more safer for you to always start with 7, and if there's deletion, there's the need for deletion, but you can also end until 3. Or sometimes usually if we adapt or adopt, usually from 7 we can maintain 7. Okay, but the minimum that you need to preserve for a construct, the number of indicator that you need to preserve, you need to maintain in your final model is 3. Okay, so it is advisable for you if you want to run the structural equation modeling. So you need to have more than 3 indicators. That is why we recommend students, okay, to actually pick. For example, we have satisfaction. Okay, for today only picking on satisfaction. So we have one sources, maybe scholar A. Scholar A proposed on 3 items. So you get it from these scholars, scholar A. Then you maybe refer to another scholar, maybe scholar B, and maybe here he or she proposed on 5. Okay, 5 items. So you combine all these items, okay, to as the indicator for SAT here. Okay, but still once you combine items from multiple sources here to depict or to measure a single construct, so you need to run the AFA to make sure the unidimensionality. All right. Okay, next. Okay, these are the most commonly assumption that are tested if you are using the structural equation modeling. But these 3 assumptions are only tested after you get the data. Okay, so what are they? The first one is normality. So you need to test whether your data distribute normally. Okay. Secondly, you need to also check on the outliers to make sure there is no extreme value. Okay. Anyone want to ask or what?
Can I ask you a question? Tadi doktor
Yes.
cakap pasal unidimensional. Apa maksud dia?
Unidimensional tu maksudnya all the items really measure a single construct. Okay, so all these items, okay. So nak check all the items only measure this construct. Tak ada cross loading. So that is unidimensionality. Bila you nak
That
check.
one kita boleh determine from EFA factor loading lah kan, Doktor?
Yup. Yes.
Alright.
That is why it is advisable for you to run the EFA. Why? Because to test the unidimensionality, why you need to test? Because you combining the items from multiple sources. Yes, this item from scholar A also measure the satisfaction. Scholar B also measure the satisfaction, but maybe different context. So you are combining all these items, all these indicators as your items to measure the construct. The similar construct is SAT, but in different context lah.
Okay,
Okay,
understood.
that is why to
Doktor.
test the unidimensionality, whether this item really measure this construct, you need to run the EFA.
I see. Okay, thank you
Only
very
then
much,
you can
Doktor.
assure that all these items really only measure this construct, not other construct. Okay.
Alright.
If the
Okay.
cross loading is higher than the factor loading, so you need to delete that items. Meaning that it does not measure that particular construct.
Okay.
Bukan item yang bagus lah. Right?
Understood. Okay, thank you very much, Doktor.
Okay, welcome. Alright, so next the outliers. Outliers kena check. Whatever, if you are doing the multiple regression or you are doing the structural equation modeling, so you need to check on the outliers. And the most easiest things to do before you key in your data, okay, if before you key in your data, so always check for the similar response for all the question, because there are tendency yang mana respondent tend to give the similar response to almost all the question from question 1 until question 100. So their answer or their response is maybe on a scale of 1 to 7, the answer is always 3 until the end. So you need to omit that one. So it is inappropriate to enter. So consider it as outliers. Okay. Similar answer. Okay. Secondly, when you have more than 10% of missing value. Okay. So you excluded this response to get what we call as the valid response. Okay. Right. So once you have the valid response, then you run the normality outliers. So only then the outliers will become smaller lah in the number of value lah. Right. Okay, the small number. Okay, next we check on the multicollinearity. Okay, what is multicollinearity? Multicollinearity is actually the redundancy between a variable. Okay, for example, maybe we have, items like I like nasi lemak. Oh, I like nasi lemak tiba-tiba kan. Okay, I like nasi lemak. Okay, then the second question is I love nasi lemak. Right. So if the multicollinearity is higher, meaning that the value is greater than 0.9, okay, the intercorrelation, okay, is more than 0.9, then you can be sure that these two items are redundant. Maybe. Okay, for example, okay, because I like and I love is almost similar. Because in certain contexts, okay, respondent would treat it similarly. I like and I love, okay, but in certain contexts, okay, they treated I like and I love differently. So it depends on the research context. That is why you need to check for multicollinearity. If you have the value for the multicollinearity and you have the higher intercorrelation between maybe these two variables, so you need to omit one, or you want to delete both, or you want to combine this as, you want to treat it as a single construct, a single item, sorry, as a single, meaning that you combine these two and get the mean value. for these two. Okay, so either you want to omit one, you want to omit both, or you want to combine. All right, for multi-cognitive, you want to solve the multi-cognitive problem. All right, so there's also assumption on the linearity and homoscedasticity. For master level, it's okay if you want to still check the linearity and homoscedasticity, but for PhD, it's a must lah, compulsory lah, to check on the linearity and homoscedasticity. Right. Ada link kehadiran? I don't know. Okay. So we allow Puan Su to respond about that. Okay, link kehadiran tu. Alright. Next, we move on to the step to conduct SEM. These are the stages. Okay. Basically, we can run the structural equation modeling simultaneously, all at once, boleh, no problem. But usually, link kehadiran akan diberikan nanti. Okay. Right. But usually, we follow what we call as two-stage approach. This is the common one. There is, first, you need to validate the measurement model, and secondly, you validate the structural model. Okay. Right. But, okay, usually I propose my student to proceed with the 6 stages process. Okay, why do I recommend this 6-stage process? Why? Because if you follow all the steps from scratch, you can get a very good items, you can get a very good indicator to really define your construct. Only then, when once you test your hypothesis here, okay, once you test your hypothesis here, you can easily get the fitness and you can easily get the reliability and discriminant validity. So yes, you need to start in the hard way. Okay, susah sikit lah kan orang kata kan. Why? Because you need to start by defining the individual construct. But if you are doing a thesis, if you are doing master, if you are doing the PhD, you still need to define the individual construct. So it is a compulsory construct. So better follow the 6 stages. Okay, no harms punya. Okay, so define the individual construct. What do you mean? What do I mean by defining the individual construct? Meaning that you need to understand your construct and you need to have the operational definition of the construct. You really need to have the operational definition. So what is operational definition? The definition of that particular construct in the context of your study. Okay. For example, we have brand attachment. Okay, maybe for scholar A, it has some meaning. But in your research, you need to clearly define what do you mean by brand attachment. If your study is in the context of bank, okay, so brand attachment maybe, okay, the customer perceptions or the customer attachment, feeling belonging, the sense of belonging towards the bank maybe. So because you need what is operational definition, it should define the variable in the context of your study. Maybe it includes the bank, yes, and also the respondent, so brand attachment. So it is the operational definition. So you need to clearly have the operational definition for each of your construct. The next thing you do is to develop the measurement model. Okay, you should be able to draw the relationship between each, the relationship between all the variables. Okay, in your that's stated in your research objective. Okay, that is why you need to have a clear research objective in order for you to easily draw the framework. Okay, so you need to develop the measurement model. Okay, right. Next, you do the empirical study. you need to do the empirical study. So what is empirical study? So you need to follow the scientific procedure, meaning that you know the population, you know the sample size, you collect your data using you select the sample, you select the respondent using the right sampling technique, and then you analyze. Those are called as the empirical study. Okay, so you have the property sampling and everything. Okay, so you collect your data. Next, okay, only then you validate the measurement model and also you validate the structural model. Okay, it seems a long way to go, but for defining is actually one of the steps in your thesis. Okay, secondly, the measurement model is also in your thesis. Okay, so there's no harm. Tak buat benda lebih pun. Okay, the similar thing. Okay, next is the software for conducting SEM. Okay, so for conducting CB-SEM, so we have multiple of software. Okay, the first one is analysis of moment structure, or easily known as, always widely known as AMOS. Okay, why we recommend AMOS? Because it is the user-friendly graphical interface nowadays with the plug-in, so it is easiest to use, okay, the structural model, because you can easily display your input and your output, get the input and get the output. All right, so next is EQS. Okay, EQS is only used by the multinational company. Why? Because it provides the extensive data. Okay, we also have the SAS. Okay, for Malaysia, we also use SAS for data analytic. Okay, almost many company use SAS. Okay, so we can also use SAS to do the structural equation modeling, but it is a bit harder for the layman like us. Okay, next we have LISREL. So LISREL is one of the earliest software to run structural equation modeling. Okay, and next we have M+. Okay, so the focus for today's workshop is on the analysis of moment structure, or easily known or commonly known as AMOS. Okay, so to do the AMOS, to do the analysis using the structural equation modeling using AMOS, so they are usually these are the recommended things. The need, or you need to have this thing, all this material first in order for you to run the CB-SEM. Okay, for my lecture lah, of course lah. Okay, the first one is AMOS. Why? Because you want to run the CB-SEM. Next thing is SPSS version 18 or above. Okay, for nowadays, I think I wouldn't worry, because nowadays the SPSS we have 27, we have the higher version already. Okay, why we need the SPSS? Because the data file in the SPSS, okay, because AMOS derived from SPSS and from the same company. Next is Microsoft Excel. Okay, this is recommended for me lah, based on my experience. So you need to have the Microsoft Excel. Why? Because it will assist you in reading and interpreting the SEM output. Okay, you can amend the output from AMOS using the Microsoft Excel. Okay, easiest. Okay, in modeling, in constructing model in AMOS, so these are the icon, or these are the menu that you need to know. Okay, if you want to draw the models manually. Okay, the first one is how you the one item here, the icon here, it is used to draw the latent, manifest, and measurement error. Next, we have to draw the residual, and next we have display the variable. Okay, okay, from I will show you later. Okay, next we use the calculate estimate. This is the similar function as analyzed in structural in SPSS. Okay, we need to tick the analysis properties. Analysis properties, we choose the analysis before we can calculate the estimate. Okay, to view the output, so we have all the output here. Okay, all kind of output are available here. So when you run one analysis, based on all the analysis that you want to use or you want to run, okay, so the output is here. Okay, will be available here. Next is data file, meaning that you sync your data file from SPSS. Okay, these are the format for you to, for example, maybe you want to display the goodness of fit, you need to have the title for your model, then you can use the right GOF. You have the title here. And then for maybe you want to draw the path, okay, we have the effect, we have the correlation here, arrow, right. So next is when you have the measurement model, the next thing that you want to do is you want to switch into the structural model, you just need to change the arrow here, okay, from the correlation or covariant into the effect arrow, right. For example, here now I want to show you, okay, we start by drawing or constructing the model, okay. These are the exercise. Suppose you want to investigate the factors influencing customer commitment. So there are 4 constructing the model: investment size, satisfaction, alternative attractiveness, and customer commitment. So the following are the construct and their respective indicator. So we have investment, will be measured by 5 items from A1 until A5. Next, we have satisfaction, which is measured by 4 items from A6 to A9. And we have alternative attractiveness is measured by 3 items, A10 to A12. And customer commitment is measured by 6 items, A13 to A18. Okay, to begin the analysis, draw the measurement model. Okay, now assuming we don't have the plugin, and we want to draw the measurement model manually. So what you can do, okay? So first, before I can show you, so I need to stop sharing first. Okay. Now I will share my screen. All right. Okay. Now we want to open the AMOS software. Okay, where can we get the AMOS software? When you install your AMOS, so you can have what we call as the AMOS graphic. Okay. This is where you want to do the analysis using the AMOS graphic. Okay, so you click the AMOS graphic. Okay. Okay. As for me, I'm still using the version 21. Okay. Maybe you can use the latest version. Okay. This is mine. Okay. Usually we start with new. Okay. We want to draw based on this instruction here. So we have 4 variable or 4 construct. So first we have investment size. Investment size is made by 5 items. It's made up by 5 items. So what you should do is here, you click here, the arrow, the icon here, draw a latent variable or an indicator. So you click here and you bring your mouse here and you just draw it based on your using your cursor here. Okay, using your cursor pula, using your mouse. Okay, saya tak pakai mouse kalau post dah. Right, so for this case you have 5 items, that is A1 to A5. So here you need to click 5 items or 5 indicator, 1, 2, 3, 4, 5. Okay, so if you want to move this framework here or this model here, okay, model into the canvas here. So what you can do is you just click here, the lorry here, the lorry icon here, in order to move the object. So you want to move the object. And when you want to move and you want to maintain this, what we call as the symmetry, so you need to click the preserve symmetry here. Only then you can move it as it is. Okay, for example here. Okay, next maybe you want to rotate. You don't want all the indicators here to be up, okay, or up the left or latent, but you want maybe to be on the left side of your latent variable. So what you can do is you need to choose the rotate icon. So just click here, 1, 2, 3. Okay, so as you can see here, you need to move a little bit. Okay, okay, maybe you want to move here this one little bit to make it more closer to the variable. Okay, so that you can move it. Yeah. Okay. Next, okay, you want to have the satisfaction. Okay, you can draw it again, or what you can do is you can also copy or duplicate this model here. Okay, what you can do, you can choose all the object and then you click copy, duplicate, sorry, the posted machine here. Okay, so just bring it. Oops, 1, 2. Okay. 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 Right. So the first one you have investment, the second one you have satisfaction. But the satisfaction is only measured by 4 items instead of investment size, which measured by 5 items. So now maybe you need to delete 1 items here. Okay, so made up by 4 items. Next, so you have alternative attractiveness only by 3 items. So maybe I want to copy as well. I want to copy this one. And okay, want to copy one by one. You need to choose one. Okay. And then you just copy. Ah, I missed this one. Okay. Then we just duplicate. And then you need to delete another items to make it 3. Okay. Then you have the customer commitment is measured by 6 items. So you can copy or you can also draw manually. 1, then we have 6. 1, 2, 3, 4, 5, 6. You want to rotate and rotate. You want to move, so you click moving here. Oops, because you want to preserve the symmetry. Okay. Next, you can label this one by clicking, double click here. You name the variable. The first one is investment. Then the second one is satisfaction, SAT. Third one is alternative attractiveness. And the fourth is commitment. Okay, right. So next you want maybe to add all the indicator here. Okay, so to add here, you can, you can write on your own, or you can simply base on the list of variable in the data set. Okay, however, we haven't yet link or sync our data file, so you need to choose your data file here. Okay. Open your data file. Okay. Then we click OK. Then we can easily click the items. For investment, we have A1, we have A2, we have A3, we have A4 and A5 here. Next, we have A6, we have A7, A8, A9, okay. Sorry, ada nak tanya ke? Okay. This is the hardest way lah yang orang tak berapa suka, but I will show you later on how to use the plugin lah. But you still need to know the basic lah. Okay. Done. Okay. The next thing, maybe you need to also define here, or you need to label all the variable, the indicator. So you can also use the plugin name and observe variable. Okay. Already labeled. Next, you want maybe to covary, okay, to have the covariant. Okay, so what you can do, you can choose the Latin variable and you click plugin, draw covariant. Okay, then the covariant is drawn. Okay, so these are what we call as, oh, sometimes maybe you say, oh, I don't want to to have this one here. So what you can do, you just delete. Okay, maybe you don't want. You want the variable to appear on the right hand side, maybe. So you need to first, and you can draw on your own. How to draw? You can use this arrow here. Okay, for example, here. Oh, sorry. Yeah. 2, 3, 4. One, two, three, four. Oh, we haven't deleted. Okay, so you can draw 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. You can always use the touch up variable here to touch up your model. Okay, baru nampak cantik. Okay, here you go. Now we have the model, the framework. Okay. Okay, this is called as the measurement model. This is called as the measurement model. Okay, how to use the plugin? Okay, the question, how to use the plugin? The easiest way, we can draw easily using the plugin. So what is the plugin to use to draw this model? The plugin is the pattern metric model builder. So make sure once you install your AMOS, make sure you have to add in the pattern metric model builder plugin. Okay, so what you can do, all right, assuming we have the data file, okay, we have the data file, we want to open the data file, CB-SEM, okay, okay, we have the data file. Okay, now I can see. Okay, so these are the data file. Okay, so these are the data file. Okay, the previously that we sync, that we link with the model here. Okay, so I want to show you this is how you can draw manually. Okay, This is how you can draw manually. But now I want to show you how to draw this model using the plugin. So why is the plugin? The pattern metric model builder. So no matter how complex is your model, so you can easily draw using the pattern metric model builder. So where to start? Usually we start by having the measurement model. Okay, if you, as in the slide previously, I did mention that the step to conduct the research, okay, I advise you to follow the six stages process. Okay, one of the steps is to develop the measurement model. So to do the empirical study and to develop the measurement model. So this step actually appear in your pilot study. So you need to run the pilot study and you need to prove your pilot study first. Okay. And usually the most easiest to do the pilot study, usually you come out with the AFA. Okay. So based on the AFA, we can get the data and we can use that data to use the plugin to draw the model. Okay. For example, here, okay, I won't show you. Okay, so I won't explain much on the how to run the factor analysis. Okay, so these are the steps. Okay, but I won't explain in detail. Okay, so you go to dimension reduction and factor analysis. Okay, right. So you need to select all the items, all the indicator here, okay, that will measure the construct. Okay, so for master level, KMO and Bartlett test is the most is a must to check. If you are PhD, maybe you want to check the anti-image or can also check on the others. Okay, right. For extraction, usually we use the agent value 1. But sometimes if you are guided by the theory, maybe you can choose fix the number of factor when you already have the number of factor, meaning that maybe you have 4 factor, for example, here for this uh, this um, for this research, so they have 4 factor, so you can easily fix into 4 factor, or the most ideal one is you can also use the based on engine value 1. So assuming I want to use the engine value 1, okay, the ideal one, okay, maybe usually we use the principal component because we want to determine on the unidimensionality. So you click continue. Okay, so you go to rotation. Usually the most common method is the Varimax. So you can also use direct oblique. You decide based on your justification. So you click the continue. Okay, and then you go to option and you click suppress small coefficient because we want to omit the what we call the little value or the smallest value, the small coefficient. We want to maintain certain value that are higher than what point. For example, I want to only show the value of above 0.4. Okay, so you click OK. So there you go. You have the KMO value. Okay, you have the community. So I won't explain this one, but what I'm interested in is the rotated component metric. Okay, the rotated component metric. Eh, we already suppressed the small coefficient, right? Let's check one again. Okay, option. Sorry, 0.4, not 0.04. Okay, so I will continue, then click OK. Rotated component metric, there you go. You have the value. Okay, so you can copy this one. Okay, so you can go to Excel. Okay. Why do you copy and paste in Excel? Because it is easier for you to check and easier for you to rearrange the data. Okay, why do you need to rearrange the data? You are not manipulating the data, but you are actually arranging in a proper way. So let me show you. If you are using this value as it is, okay, surely you want to delete the lowest cross-loading here, okay, the lower cross-loading here, okay. For example, so you have this value, this result based on this rotated component matrix. So you can copy this rotated component matrix. Okay, you can copy here and you can go to AMOS. You can plug in, okay, pattern matrix model builder. You can paste here, okay, as it is without rearrangement, without rearrange the output. Okay, so you create the diagram. And tada, this is what you get. You will get the factor for number one that is measured by A13, A14, A15, and A16. You are not in a proper arrangement. Suppose the first from item A1, okay, indicator A1 to A5, you want it to appear maybe above, okay, so that it is easier for you to monitor your data or to monitor your output and to read your output, okay. You can leave it as it is, but it is better for you, okay. For example, here they are not labeled the variable. They are based on the factor solution produced in the EFA. Okay, they are basically referring to here. Okay, because you have first factor that consists of, they are measured by A13 until A18. Then we have the second factor that is measured by A6 until A9. Then we have the third factor that is A1 until A5. So now I want to show you why do you need to rearrange. Okay, you are not manipulating the data, so you just bring it here. So you want it to be the first factor. Okay, this is the investment. Okay, based on the first the research here. Okay. Okay, we have investment, we have satisfaction. Okay, so next is, this is satisfaction. The third one, we have alternative, so I bring it here. The alternative. And the fourth is com. Okay, so you bring all the values here. If you are doing the EFA, oops, what happened? What happened here? Wait, I want to check what happened. Why do we have one? Okay. So I need to copy back this one, rotated component matrix, copy, and we go here. Okay. Okay, what happened? What happened? Copy here, and then we paste here. Okay, so we have the rotated component matrix. We rearrange this one. We delete the lowest here. Here. Okay. So we have here investment, we have here satisfaction, SET, we have investment, and then we have com. Okay. Now you copy back this one. Okay. Right. Then you go to AMOS, and then you go to plug in pattern metric model builder. Then you paste, okay, the result that you have amend a little bit. You have labeled all the construct, and you rearrange the value here. Okay, so actually this is, if you are doing the EFA, you need to rearrange the output here. Okay, and you have the staircase form. Okay, kena buat macam ni so that it is easier for you to report. Kalau dia caca merbau macam tadi tu, it is not the most recommended presentation in your thesis lah. So kena amend macam ni sikit lah. Alright. Okay, so just create diagram. And tada, you have everything in sequence. Okay, the variable is already labeled, so you have everything in here. Okay, maybe you just need to add in the GOF value, so you just click the title and you have the GOF value here. Okay, so what is the GOF value? These are the value. Okay, for goodness of faith, this is the most commonly used index to indicate the goodness of faith. Okay, maybe you want to add in the label here. Okay, so just click or paste, and then maybe you want to left align. Okay, the font is okay, then click OK. Okay, so you want to move. So there you go. You have the value. Okay, you have the measurement model. Okay, right. The next thing I want to show you, I need to inform you that, okay, based on here, as you can see, we have two type of sheet here. So the first one is the view on the input. Now we have the input. We still don't have the output. Why? Because we haven't run the analysis. To choose the analysis, to decide on the analysis, so you need to click the analysis properties. Okay. Usually for measurement model, you click the output here. Okay. Usually for the measurement model, okay, you need to click the standardized estimate. Okay. The residual moment, the modification index, and test for normality and outliers. Okay. Whereas for structural model, you need to click on the the standardized estimate and the squared multiple correlation only. If you are doing the mediation, so you must also click the indirect, the direct, and total effect to get the value. Okay, right. So next, what should we do next? Okay. So for this model, so you want to click the standardized estimate, then we have the residual moment, we have the modification index, and the test for normality. Okay, then we close. Okay, if you run this model, you just click the calculate estimate. So this calculate estimate function, the function is similar to analyze in SPSS. So just click. There is more than variable name INV. Oh, sorry. Oh, previously this is not IMV. This is ALT here. Okay. Sorry for the mistake. So you just need to rename this one ALT. So you can run you can calculate it. First you need to name the variable, name the file. Try one. Okay, then okay, now if you check here, Okay, meaning that the AMOS have done with the analysis and these are the output. If the output here, the output view here is not active, meaning that the analysis is not run. There is something wrong with your analysis. Okay, so similar with the multiple regressions, okay, we have the standardized and unstandardized estimate. So the unstandardized estimate is, although different terms used, but it is actually referred to the similar one. Okay, next we have the standardized estimate. Okay, let's move on. Okay, now you have done with, the draw the measurement model. If you want to convert, okay, if you want to convert, I will tell you later, I will explain to you later, is just, you just need to remove the covariant to the dependent variable, and you bring the dependent variable to the other side, the right hand side, and then you need to add in the arrow here, and then you need to add the residual. Okay, only that. Okay, let's try. Okay, if you want to convert this measurement model into the structural model, what you can do is, first, you need to erase the covariant to the dependent variable or the endogenous variable. So you need to move the variable here, the dependent variable here. Okay, so you don't want it to be redundant, so you need to rotate this one. Okay, so you need to maybe to move a bit here, make it more closer. Okay. Okay, maybe this one, the covariant here is agak mengganggu, so you just delete first, and then you need to add in later on. Okay, so you move first, then you use the effect arrow. Okay, you want to check the effect of investment on COM, then satisfaction on commitment, and the alternative on the commitment. So you just need a touch up, okay? Touch up everything. Next, okay, because this is a structural model, so you need to have the residual error here. So just click here, and then you need to label here. So you use just add in. Okay, you have add in the residual error here. The next thing you need to add in again the dia punya covariant here. Okay, kan nak mudah, you just need to choose the variable and just use the plugin lah. Just draw covariant here. Okay, there you go. So previously you have the measurement model, so now you have the structural model. Okay, so just save. Try two. Okay, we have try one and we have try two. Okay, this is a structural model. Okay, you just need to save. Okay, so we have done. Okay, we have done with the part one. Okay, kita akan continue dengan how to conduct the structural equation modeling. So basically, we have two steps. First, you need to validate the measurement model. The second one is you need to test the structural model. So there are two steps. Okay, so in the validating the measurement model, there are few steps. Okay, under the validating the measurement model. So before we can start with validating the measurement model and structural model, the first step, okay, is to check on the assumption. So what are the assumption? Basically the normality, the outliers, the multicollinearity. Okay, so these are the yang paling perlulah kena buat. Okay, okay. Secondly, only then you will proceed with SEM. So under SEM, okay, there are two steps. Okay, the first step is validating the measurement model. Under validating the measurement model, the first step is to determine the goodness of fit. Okay. If you cannot achieve the goodness of fit, so you need to improve the fit. Once you have improved the goodness of fit, only then you can proceed with validity and reliability. Validity and reliability. So once you have achieved the validity and reliability, you have already completed the first step in SEM, that is validating the measurement model. Right. So you can only then, after you have achieved the reliability and validity, you can test the structural model. Okay. So in testing, in doing the hypothesis testing or validating the structural model, okay, there are two steps. Okay. The first one, you need to also check on the goodness of fit. Okay. Usually, once you have achieved the goodness of fit in your measurement model, you must achieve the goodness of fit in your structural model. Okay, mestilah, surely. Okay, once you have achieved the goodness of fit for your measurement model, you can surely achieve the goodness of fit for the structural model. Okay, right. So there is no such thing as improving the goodness of fit in the structural model. Tak ada, orang tak buat. Okay, you just need the goodness of fit. You just improve the goodness of fit during your validating the measurement model, but not in the structural model. Okay, so once you have proven the goodness of fit, okay, the next thing is to test the hypothesis. So depending on the hypothesis, if you have only the direct effect, so you just test only the direct effect. Okay. If you have mediation, you have the moderation, meaning that first you need to test the direct effect, only then you can go to test the mediation or the moderation. This is the QR code for the second slide. So we move on to the first step, that is to check the assumption. Okay, right. So we have three compulsory SEM assumptions that are normality, outliers, and multicollinearity. Okay, so these are the cutoff value. Okay, if you want to do the analysis, so you need to compile all the cutoff value and explain in your chapter 3. Okay, so it will be easier for you to report in your chapter 4, the finding. Okay, right. Okay, terima kasih. Semoga sharing ini bermanfaat untuk semua.
Okay.
Assalamualaikum.
Terima kasih,
Bye-bye.
Doktor.
Take care.
Terima kasih.